Welcome, everybody. Tonight we're working on Module 5. The topic for tonight is arrays and collections. As we kind of start to go through the slides here, these are our major topics. So we'll look at what an array is. We'll look at what, collectively we think of as a collection, and then tools that we use with these to do practical work. I think this is kind of an interesting image, right? Because does anybody recognize what we're looking at here on the screen? Nobody works with servers at all here? Nobody? All right. Well, if you work with servers, right, servers are basically big computer systems that have big capabilities and they put them into racks and they fill the racks with these machines. What we're looking at here is actually an array of hard drives. And I think this is really kind of a really cool analogy to start with for a bunch of different reasons. We are now moving into this era of rapid growth of artificial intelligence, rapid growth of the data that society produces. One estimation I've heard is that with every year that passes, our technological society is generating as much data in the last year as we have as a society as a whole in all the preceding years up until that point. And I want you to think about that. And that process keeps happening, right? So like this year we can say we reproduce more data than all the years up to 2024. And if that happens again next year, I'm saying how much data are we? It's like an exponential growth of data, right? And what this is, and this is really kind of a nice analogy for what we're starting to learn about, where normally when you run a computer system, you might have a hard drive, right? And if you have like a gaming machine like mine, well, you have a couple, 2, 3 hard drives in the machine, right? Because you have one for storage and one for running your software and one for your movies and whatever, right? But when you run a server, all of a sudden, like you're storing so much information that you store your hard drives in an array, right? And notice there's one physical machine here, and then there's hard drives. I don't know how many hard drives that is. That's probably 24 hard drives, something like that. But I don't know if you can see this little number up here by my pointer. What number does that start with? Yeah, that's a 0, right? And that's one of the concepts we're going to learn tonight is they start counting the array of hard drives. Hard drive 1 is actually in position 0 in the array. And that's one of the things we're going to learn tonight. And I think it's really kind of a fascinating correlation, but we are in this era now that we need a lot of storage, right? Everybody has files to store and lots of information to store. So we have to always find more efficient ways to do that. In essence, what an array is a named data object, like a variable, that can hold many values instead of a singular value. What we learned originally, right, like one of the first kind of variable types that we created was probably an integer, right? And so the bottom declaration here, where it says int num, we can kind of identify that as okay, we're naming a spot in memory, and now I can store in that spot any value that's of type integer. With an array, the way I declare it, very, very similar, but notice the square brackets after the int. And what this is saying that this is going to be an array of integers. So kind of like this hard drive array here, it's like one machine, but it will hold many hard drives, not just one, but many. And at this point, the way this is being declared, we don't know how big it's going to be, but we've set it up so that it can be one of those structures. Now, because there's multiple storage positions in here, there's some issues that we have in accessing those storage positions. In the image that we looked at, I don't know, like I was trying to point out, this is a 0, that's a 1, 2, 3, 4. How do we know which hard drive we're going to? Well, they're numbered. There's an index for them. So if I want to go to the 5th hard drive, I go to index position, 4. That's where it gets really weird, right? Because of the number counting, and we'll understand why. As we create an array, the previous slide, we were just declaring an empty one. On this next slide, here we're using this keyword new to declare an integer array of size 6. So the 6 actually is a way of saying how many spots in there do you need, right? So the new keyword, by the way, this is kind of interesting because we haven't really talked about objects and classes yet, but whenever you see the new keyword, what it implies is that a constructor function is at play. So that means that there's this class library, and when I say new integer array of size 6, that new keyword uses the constructor function in the class library to build the structure. It's kind of like saying, okay, build me a house that's 6 stories tall or has 6 apartments in it. You know, that's essentially what we're doing. And notice, you know, as a result, we can hold 6 integer values in that array. Another really fascinating thing about working with an array is it doesn't have to be of type integer, right? So just like any sort of a variable, it can be of any valid data type in this language. It can be a string, it can be a character, it can be any of the number formats that we've learned. It could even be Booleans or whatever. And as you get into like deeper levels of this, you'll start to learn that an array can hold much more complicated objects than just simple data types. And that's one of the fascinating concepts, and not to kind of like blow your mind right out of the gate, but I could have an array full of arrays. Okay, right? And so it's kind of like the movie Inception. It's like the dream within the dream. So I can take a complicated data structure and store it in one spot in a different complicated data structure. How weird is that, right? If you, once again, you want to use this as a correlation, apparently this server rack is full of arrays of hard drive arrays. You know, same kind of concept. So you can kind of go down the rabbit hole a little bit, but generally speaking, you can store just about anything in them as long as they're of a singular data type, which is declared, right? And notice like all of these would be valid declarations for creating arrays. And yeah, you can create an array with 100 places or 1,200 places in it, right? If you have a functional purpose to do that, you do it, right? All right, so when we start to declare sizes, I mean, pretty logical. You can't use a negative number, right? So I can't like create like a negative amount of storage spots. You know, it has to be one or more, right? You can assign a value literally. So I can just type the number in the square brackets, or if I wanted, I could set up a variable and then feed the variable into this spot. So like maybe you have some code that runs and you got a bunch of entries from your user, and then you can count how many entries that was, and then you can build an array of that size to store those values, right? That would be one reason you might want to use a variable, right? So some important things to talk about here. You have to declare the data type and the size when you're creating it. Once you create it, the size cannot be changed. So if you put in 100 spots and you're like, oh, darn, I need 101, too bad, right? Should have thought ahead, right? Maybe make a couple extra spaces next time. You know, and once you've created it, you also cannot change the data type. Now, for those of you that come from the Python world, right, where you learn about Python lists and tuples and dictionaries and sets, right? So anybody here that's done Python and is familiar with any of that, Python doesn't care what you put in, doesn't care what size it is. It can always change it. You know, tuples are the one exception, perhaps. They're way more flexible. This language is not flexible. It is a strongly typed language, so the rules are a little bit tighter. One of the side benefits of that is when the code is compiled and runs, these data structures tend to run faster than Python data structures. You know, that's one of the side benefits of it. When we put stuff into an array, we access the items inside there by basically using index values. Some people refer to them as subscripts. Real frankly, I never do, but some people do, right? So some people will think about this array called my numbers, right? And then that contains 6 storage spots. I want you to notice though that the numbers always start with 0. So if it's of size 6, the last position is position 5, one less than the size. And that's because computers start counting at 0. Why do computers start counting at 0? Because in the base 10 number system, there's 10 possible values, 0 through 9, right? We don't start counting with 1. We've talked about this concept before, right? But here's where it really becomes important, because if I'm looking at the second position, it's position 1, not position 2, right? So this is part of the challenge of learning this. And I think it's really curious that hard drive array, that physical piece of gear, is numbered the same way. Like somebody's like, well, that's hard drive 0. Why? That's the first one. That's why. And computers just count that way, so we kind of have to roll with it and work with the code in that way. Now, if I'm looking to store a value in a particular position, right? So if I create an array of integers of size 6, and I just create it and give it a size, there is basically nothing inside of it. So what ends up inside there kind of varies on the data type that you create. So like upon first initialization, in principle, there is nothing stored there. So if I want to assign something to a particular location, look at the syntax of this, right? So this construct is called my numbers. It has 6 numbered positions going from 0 to 5. So if I say my numbers square bracket 0, I'm referring to this position like it's an individual variable, and I can assign the value of 20. So all the principles of working with variables still apply. It's just if I want to go into a certain spot, I have to use its index position to find it. That's really the difference. So 20 gets stored in position 0, 30 gets stored in position 3. Right. And then it really kind of works like a regular variable. At that point, we can grab individual pieces of information if we wish. And, I like that, we have this little thing here. It says spoken as my numbers sub 0 and my numbers sub 3. And once again, I never say those phrases. I didn't put this slideshow together. I'm just utilizing it. And I never refer to them as sub numbers. I always think of them as index position 1, index position 2. You think of it in whatever way makes sense to you for you to remember it. That's what I'm going to say. There are programmers that do refer to it this way. It really kind of depends on the school that you came from, basically, and how you were taught. All right. There are initial values that do creep into these data structures when you create them. And understanding that as you get started is kind of helpful. So like if you do anything that's got numbers involved and you create the array, but you haven't put anything in it yet, what's inside that memory spot is the number 0. That's the default for this language. That is not the default. And I want to be really clear about this. If you're doing a different programming language, that won't be the default in that language. Every language handles this differently. If I do this in Java, and I'm trying to, it's been a while since I've touched Java, maybe about a year. I think what happens is there you get a null. I'd have to double check that, right? So you wouldn't actually have anything in there. If you have a character data type, it puts in Unicode 0, right? Which is basically a non-character in the Unicode character set. And then if you do Booleans, it'll preload false. Okay, maybe that's good, maybe that's bad. I'm not really sure. And then all other objects, including strings. So any object that's more complicated than a number, a character, or a Boolean. And this tells you something about strings, by the way. Strings are actually complicated data objects already. So if you create an array with the complicated objects, the default initialization is null, which is the absence of anything. It's not 0, right? It's not false. It is just nothing, or a thing representing nothing is a better way to say it. I think what's really fascinating about this concept, though, because we are going to start talking about objects pretty soon here in this class, is when you think of a string, and I want you to notice what I'm doing right now is I'm highlighting one character at a time in the word strings to kind of give you this concept that a string is really a collection of individual characters, right? So a string in and of itself is a complicated data object. And in fact, what a string truly is an array of characters. And because of that, we can look at a string as position 0, position 1, position 2, etc. Right. So this is kind of an interesting thought. Right. So strings are technically classes in most programming languages. I know in Python we think of it as a primitive data object, but it truly is not. All right. So when we start to use these, sizes that we're declaring, right, we use the sub numbers. We go back to this concept, an array of size 6, its last position will basically be the size minus 1, right? And we always start at 0, and then we go to wherever the size is, it subtract 1 from it to get the last position number. And this is the thing you always have to remember when you're going to traverse the data structure to extract or insert information. This becomes very critical that you know the size of the array and that you understand what the last position is. Because if you try to put something into position 6, for example, in this array, it will throw an error. And I forget how it reads in C#. It'll be kind of like an out of bounds error. It's like, you're trying to put this, in this spot that doesn't exist. So that it becomes a very critical piece. All right. There's a little try it out here. And what I'd like to do here is kind of code through this just to kind of get our hands, feeling what, these structures are like. And so let's read the prompt first, and then I'll bring up the coding engine. You guys can follow along with me if you wish on this. It says create a program that asks for the donation amount for 3 philanthropists without using a loop. So we're disallowed from using a loop right now. Ask for 3 amounts and then print them out. Print out the total amount. So now if you think about what we're about to do here, we're going to create an array structure and then put the amounts in to the correlating positions in the array structure, and then we're going to pull them back out and write them to the screen. And really, the exercise here is just to get the practice in working with the array structure. So we do have to create that array structure, and there's a couple little coding things we have to do to make that happen. Let's go ahead and bring up Visual Studio or whatever coding engine you're using that supports C#, and we'll just go through our standard routine of creating a console app here. And I suppose we should probably call this what it is. Let's call it module 5, try it out, something like that. And, if you are coding along, just for the sake of practice, you can probably do most of the try it outs in the same code file. And then when you try a different approach, you can always comment it out or, your choice on how you handle it, really. I'll show you how I will handle it on mine. And all right, let's go ahead and actually I'm going to kind of backtrack here. This is going to be kind of weird, but I'm going to do this on purpose. I'm actually going to close this, and you guys are like, okay, but you just created it. Why are you why are you closing it? All right, so here's what I'm going to do. I'm going to do this process one more time, but I'm going to switch my operating mode. So I'm going to call it basically the same thing. I'm going to abbreviate. I'm going to say mod 5, try it out. And the reason I'm doing this is I do want to show you the top level statements in this case. So this box that we normally leave unchecked here, I'm going to actually check it. My intent here is to show you the whole structure of the program with the main method, right? And I just want that not to be obscured from you right now, because we're going to be building stuff that requires the use of external libraries, right? So when we start working with collections in C Sharp, it's best to be able to see your namespace and program structure when you're working with those libraries to make sure that you're actually using them and that your code operates. It's not that you can't put the using statements inside the main method, right? This is normally where we work, is inside these curly brackets, and we don't see the rest of it. But up here at the top, what we're going to do is we're going to insert some statements as needed when we start working with our data structures. And if you think about what we're being asked to do here, we're basically going to create an array. Okay, we should probably talk about what kind of array we're going to create. So looking at the monetary amounts here, what kind of data structure would be, or data type would be good to hold these monetary amounts? Probably not an integer, right? Yeah, that wouldn't make sense. Usually we go for a double or a decimal. Somebody was saying that, I think, James. Is that what you were guessing?
Yeah, double.
All right. Given the number of donations we're capturing, how big does our array have to be? Well, of size 3, right? Yes, correct. All right, so here's what I'm going to do is back here in the program, and I'm going to do this, inside the main method now. Yep, not there. Thought it was inside the curlies, but I wasn't. We'll get rid of this console write line. And I'll zoom in just a little bit because you guys are probably going to struggle to see it otherwise. But I'm going to create an array that holds doubles. And so I'll declare the data type. I'll use square brackets, and then I'm going to give it a name. And in fact, we're dealing with donations, so let's just call it donations. And then here on the other side, we're going to say equals new double, and then we're going to declare the size. And what size are we going to make it? Well, I'm going to make it of size 3 because I know I'm going to need 3 spots. It's really pretty as simple as that. If I wasn't sure how many spots I'd need, well, then I would maybe put in more than I would necessarily utilize, just so I have the capability of capturing more information if I needed to. All right. If I'm trying to come up with a total, right? So at the bottom, I'm going to get a total. I'm going to need a variable to hold that total when I'm all done. So let's create that right away too. So I'm going to say double, just call it total. That's just a regular old variable. And since we'll be calculating that, we don't have anything yet. Let's just set it to 0. I think that's a pretty reasonable thing. All right. Next thing we want to do is we kind of want to mimic what we see on the screen here. And the prompts are basically how much donated, number 1, number 2, and number 3. And so I do have those pre-created here for the sake of you guys following along efficiently. Here they are in the chat, so you don't have to type them, assuming you're using the same variable names as I am. Right, so there's the 3 prompts. Now, I want you to notice how we're storing them, right? Because I didn't type these out manually. I am putting them in position 0, 1, and 2. When I create an array from scratch of size 3, those are the 3 position index numbers or sub numbers, if you will, that we have. Always starts at 0. Second position is number 1. Third position is number 2. The last position is 1 number smaller by index number than the size of the structure. Always. Okay, so these are the 3 prompts to capture the information. Now, we just basically want to put those back on the screen, if I remember right. So you can do this in a number of different ways, right? So there's different ways you can put that back up on the screen. I think the easiest way to do it is sort of like this. So here it is once again in the chat. If you guys want to save the typing, this is the code I'm dropping in. So I'm just going to take those donations. I'm going to pull them out of memory, right, with their sub numbers, and I'm going to format them as currency. So that'll put them back up on the screen. 3 prompts to grab them, and then 3 statements to put them back on the screen. And then, of course, we're being asked to generate a total. So how would I generate the total? Well, I just add those things together, right? So I can take donations 0 plus donations 1 plus donations 2. And I'm hoping you guys can type that one on your own. It's not too hard to do. And then we can put the total back up on the screen, and we can just do something simple like uh, total equals, or if you want to use a colon, your choice, whatever. Doesn't really matter too much. I will say total colon C. And I think that looks okay. That should work. Yeah, and I'm just seeing the message up at the top of my screen here that my version of Visual Studio needs an upgrade. So I better, oh, check that out, you guys, at version 2026. Hmm. Okay, so here's my one tip. This is kind of off topic here a little bit, but should I immediately install the new version?
No.
Steve,
No, hold
Steve,
off on updates.
yeah, right. I'll wait till the semester's over, wait till all my work is done, and then I'll try it on a different machine first. That's usually the way that I do it, or I'll run a virtual machine or something and try it on a virtual machine. It should not be that much of a jump, but you know what? For next semester, I'm definitely going to load it up. Now that I'm in, what I call production mode, I'm certainly not going to switch midstream. Right. So this is
Takis, I did mine 2 days ago, and it updated just fine, just so you know. But
okay.
yeah, I got the same message, and it was real quick. I waited till I was done doing what I needed to do, and then it updated just fine.
Yeah, I get a little concerned mostly with the fact that they're going to be including the new versions. Um, and really, whenever you see a version change, this is actually kind of an interesting tip. Whenever you see a version change in Visual Studio, that means a new version of Windows is just about to come out also. Typically, they often match. They create a new version of the tool to create a new version of the operating system, and it runs newer libraries. All right, so here's the program. Let's get this to run, and let's bring it up, and then we'll follow along here. I'm not going to use the same numbers that are in the example, but we'll use some different numbers. And there's a little algorithm to the way I put the numbers on the screen. If you guys study your keypad, you would see it. But notice we were able to store these in those positions and extract them, do some math with them, and put them back on the screen. So really, in principle, we're just working with variables, right? But they're all in the same data structure. Here's the advantage of that. If I want to move that data structure around or refer to it in whatever way, it's one singular thing. This is an advantage, right? So rather than like going into that array of hard drives and pulling out an individual hard drive, I just move the whole array at once, right? And access all the information within it. All right. So hopefully that was a nice little demo for you guys just to kind of get your feet wet with arrays. Now, when we're working with arrays, one of the advantages of working with them is because they're of a predictable size and structure and predictable contents, we can very easily apply loops to them to both read information into them and extract information out of them automatically in some cases. Caleb, I see you have your hand up.
Yeah, just a quick question with regards to using total as its own variable. Could we have, or would there have been any advantage to, I don't even know if this is possible. Could we have put total into a position 4 of the array, and make it 4 spots and then put that calculation in that fourth, what would be the third position?
Yeah, there's nothing that says that you can't do that. From a
Okay.
conceptual standpoint, though, my caution to you would be, would you want to do that?
Right.
That would be my contention, because if the array just holds donation amounts, right, the total of those donation amounts really is a byproduct of whatever's in the array. And yeah, you could use one of the positions to do that. There's nothing that says you couldn't,
Okay.
you know. I wouldn't do it just from the standpoint of like the higher level abstraction of the concept, right?
Sure.
And this is actually kind of an important thing, right? Because really what we're doing here with arrays is we're doing a data abstraction. This is what we call it, where we are collecting a bunch of things together and referring to them collectively with a singular name, but really they're a bunch of individual entities. The same way you would think of, let's say, like the Green Bay Packers as a team and not worry about like Jordan Love or Jacobs or, whatever as individual players. We think of them as a higher level collective, Um, and this is one of the advantages of working with arrays, because you can, okay, this array holds all the donations. All right, I get that. You know what I mean? I don't need to look at every individual one to get the concept. We're looking at it from a 10,000-foot view, so to speak. All right, this is kind of interesting, but this concept once again of taking looping and applying it to the structure of an array really kind of unlocks a lot of power of these data structures, because often when we're inserting and removing data, it is a repetitive process. One of the things that they point out here is that subscripts can be stored in a variable, and for example, take a look here. For example, if x is 0, x is 1, x is 2, right? And we can basically deal with the index positions as variables in a separate array structure. And this is kind of a weird thought, but when you start to apply a loop to it, right, you can kind of set up this kind of thing here where the index is something that we can loop through as a variable. So this is kind of the point, and I'm maybe not saying it as clearly as I possibly could, but if I was to apply a for loop to this array, right, I would set up my for loop, with some sort of a loop control variable, right? In this case, the index, which I'll set at 0. I will tell you, probably the more common approach that I see in programming is people will just say int I, which represents index, right? That comes from mathematics, basically. And this loop will run as long as the index is less than 3, which is the length of the array. So 3 is the length of the array. And then every time we go through the loop, we increase that index number by 1. And what is this doing? Well, this is populating this index value automatically every time it goes through the loop. So it starts at 0, then it becomes 1, then it becomes 2, and so on, depending on your thing. And then what is this doing? This is console redlining. So this is like doing a prompt and grabbing information. So I can automate that process, like instead of like each time typing that in together or separately. So I had to write 3 prompts, right, to do this. Well, that's silly. You just write the prompt once, put it in a loop, and then have it put the stuff into the array automatically, and then just keep going until we feed it in. Right? I mean, that kind of makes sense. So that's kind of the next try it out, is to basically modify that little program that we just created to make it happen in that fashion. So if we go back to this code, where are the spots where we can gain some efficiency? Well, all right, well, let's get rid of this, right? Because I don't need to do the prompts 3 times. And then if you think about it, I also don't need to do the write lines 3 times, because we're traversing the same structure. It fits really well to put it into a loop. And so here's the example that I'll put together here. Is I'll start with a for loop. And yeah, I am doing some copy pasting here just to kind of speed things up, right? And what I'm doing is I'm setting up the loop with I as my counter variable or loop control variable, right? And as long as I is less than donations length, and I'll notice that this is what we call a property. We haven't talked about this yet, but this determines the length of that structure, and then that will read the fact that it's 3 because we declared it as a size 3. And as long as I is less than 3, it will prompt and then store. And instead of putting a hard-coded index value here, I just simply use a variable instead. And it will capture the same thing. And in fact, here, instead of saying how much was donated, number 1, I can use some string interpolation here, and then in the form of a variable, just say, well, I could just put an I, right? Because that would just read the number. So how much is, well, it would be I plus 1, right? Because that would read 0 the first time, and then the next time, well, we have to add 1. So if we want to say 1, 2, 3, that's the way to do it automatically. And actually, right, this colon really should be here, like that. And then we need a curly bracket to close it all. So one prompt repeats, it automatically goes through each array position. Same thing can be applied to the right line. So I'm going to do that with a different counter variable. I'm going to use a J on that one. That's a pretty common thing, right? I stands for index, and if you use a second loop, go to J, then go to K, for whatever reason, that's what they do. And then we'll tweak this one to do the same thing, right? So instead of having a 0 here, we'll just put in the I. And then if you want it to number automatically, we'll do the same syntax we did there, which is this should be J. All right, so J. So I have to fix the other one too. J plus 1. And then this should be J, not I. We really didn't save a lot of lines of code. Okay, but imagine if the donation thing had 100 character or 100 positions in it. Would you want to write that prompt 100 times? Yeah, you don't have to, right? This is kind of the whole point. So one of the other things that we're learning here is that when you have these, data structures, you can traverse them with loops really efficiently. And loops and arrays go together like, ice cream with a cherry on top or hot fudge. They just work together. All right. Let's try running the program now. So I'm just going to do the run on that. You'll see it'll work exactly the same way. Right. No difference from the user perspective at all. But on the coding side of things, a lot more efficient. And once again, if we had a array structure of size 100, I wouldn't have to write the prompts 100 times. And we can still put all the stuff into the correct positions. All right, let's keep rolling here. And there's a little bit of an issue that we do run into. And when you work with loops, even if you're experienced, by the way, you can run into this problem pretty easily. So when something is of length 6, right? So we're going to keep hammering this point here. The last position is position 5. When something's of length 4, the last position is position 3. So whatever the length is, minus 1. And so we call this bounds checking, because if we start to do an action, right, like here, if we took those 4 loops and instead of having it index less than 3, we said less than or equal to 3, each one of those loops would run one more time, right? It would basically reach position 4, right? That isn't there, but we would call it index position 3. And then you would get this error. And notice it'll compile. This is the weird thing about it. You won't get an error in your code. So if I go back to Visual Studio and change this to equals to, it's not telling me it's wrong. But if I try to run that, it will break. When does it break? At runtime. Right. And this is actually kind of an interesting discussion too, because there's syntax that I can do wrong. For example, like I can omit a semicolon, right? And then it'll give me red and it won't compile and it won't run, right? And then there's this type of an error, which is really a logic error, and it happens at runtime. There's nothing wrong with the syntax of what I wrote, but there is something wrong with the logic of what I wrote. And that's a really important distinction. So, like, if you wanted, for example, to see it in action, I can run this, and I'll just put it on the top one here, right? And it'll run to start with. Okay, no problem. One more. Now my array is full, and it's going to ask again. And what happened? It broke, and it gave me the exception unhandled. And then you can start looking at all your error messages. Technically, the program is still running, but really it's crashed, right? So I'm going to hit the little stop button, but it's out of bounds basically because it's trying to put something into a position that doesn't exist. So even though the syntax seems okay, it becomes on you as the programmer to understand the size of the object you're dealing with. Okay, so be mindful of that little issue. So knowing the length of something before you go cramming data into it becomes pretty pertinent pretty quickly. When we're off by one, we call them off by one errors, right? And this happens a lot with working with these data structures. This is the exact error message that you would get down in the output console if you're looking. And look at the example they have here. So they have a size of 100 set. So size is 100, right? This equal sign is what's breaking it because it starts at 0 like it's supposed to, and then it will count up to 100 and try to put something in position 100, and it won't work, right? And then you get that error. And I just demonstrated it so you can see that it won't underline red in your code, but your logic is flawed, so it doesn't run, and then it breaks when it runs. Okay, so just be mindful of that. Now, if you want, and this is kind of interesting, when you build an array, and here's an example, this is an integer array called days, you can preset the values in advance. So for example, if you know what values are going in, and I don't know, like maybe you might have an array for the number or the days in a month, right? That would go from 1 to 30, right? Or 1 to 29, or 1 to 20, 30 or 31 usually, but sometimes 29, and every once in a while 28, right? But if those numbers are known in advance, you can hard code them in and look at the syntax for doing so. These are integers, right? So we just put them in, comma, separate the values, put it inside a set of curly brackets, and then that array is pre-populated. Notice I don't have to declare its size. The size is intrinsic to the amount of data I'm putting in there. So this would be of size 6. This would be position 0, 1, 2, 3, 4, 5, but length is 6, right? One of the interesting things about doing this, like kind of the brute force approach with what we call literal values, right, is you don't have to use the new keyword that's implied. But we are building an array from scratch, and we are populating the values. So this is one way you can do it. There's other ways, by the way. So I could create the array, leave it empty, and then give it a size, and then populate the data one data point at a time if you wish. But if you have all the data and you can put it in a list like this, you just do it, right? There's nothing wrong with that approach. All right. Every array has a length built into it, and we call this, technically like a property, right? So if I just do, say, dot length, and I want you to notice this is kind of like, when we do like console.writeLine, but WriteLine's got parentheses. We know this is a property because it doesn't have parentheses. This is just a value that's being extracted from a data structure. And there's this thing called length, and it's really kind of like a method or a function, but it just returns the size of the object. This is very useful because sometimes you don't know what the size of the object is. Like if the user is controlling the data going into your data structure, and you don't know how many times they typed it, you have to have it dynamically adjust. So you would probe for the length and then subtract one to get that last index position. And I know I'm saying that over and over again, but people do forget very, very quickly. And trust me, you will at some point too. The other thing that, and I think that we've talked about this before, is how strings are really complicated data objects, right? So like if I have an array of numbers that are 1, 3, and 5, and I look at the length of it and store it here, this value would be 3, right? Because there's 3 things in it, right? When I look at a string, right? So this is a string. This is position 0, 1, 2, 3, etc. Right? It goes one character at a time. And what's the length of that? Well, how many characters are in there, including spaces? That's the length of it. And so I can access the contents of a string in exactly the same way I can access the contents of an array, because really a string is an array of characters. And I think that's a very important concept to wrap your head around. All right, I think we'll do a couple more slides here and then we'll take a break because we're already at the 1 hour point, believe it or not. And it says it's very common to use an array's length in a for loop condition, right? And so this is really, really useful in this situation because very often a for loop is one of the preferred loops to use with array structures, by the way. There's also a variant, right? The for each loop, which you see a couple slides down, and we're going to get to that in a moment. But when you're engineering a loop just the way that we've been doing it, as the big orange arrow indicates, you want it to be less than your index. If you start at 0, it's got to be less than the length of that structure. Otherwise, you'll get the 1 off or off by 1 error. So just be mindful of that. It's pretty easy habit to get into to not include it. Right. Of course, if your code crashes, you fix it. Right. Not that big of a deal to fix. Right. Now, if you're wondering about this length property, the length property is only capable of reading the information of the structure as it exists. It is not capable of acting like a variable where I can change the size of the structure by doing a statement like this. So you try this code and it just won't work. Length is a property. It's just reading what's there, right? It's kind of like if you look at your driver's license, you can read the information on it, but you certainly can't change it. You got to go to the DMV to change it, right? Can't do it yourself. All right, this is a good spot for a break. So let's do about a 5-minute break here, folks, and let's come back at about 8:02. All right, back from break, and now we're going to talk about the for each loop, which is a different type of looping structure. And our look at this has been very brief thus far, but if we've already identified the fact that we could take a for loop and traverse an array structure with it, right? Because an array has got a predictable, repeatable pattern that we can traverse, and a for loop can operate with that really beautifully and do a lot of stuff with it. Right. So you could write something like this, right? And so what they're doing here is they're just basically taking one of the numbers, they're adding it to this integer, they're multiplying it by 5 and doing something with it. But it is also possible to use what we call a for each loop. And the benefit of a for each loop is that I don't have to probe the array structure to get its length. I don't have to know that in advance or calculate it or adjust my loop so it doesn't mess up. Like if I put an equal sign here, now it's out of bounds, right? I can use a for each, and a for each loop is basically built to automatically traverse data structures. And notice there's a little bit of a difference in syntax. And once again, I'll do the Python correlation here. If you guys know Python already, and how Python works, you can automatically invoke a for each loop in that language just by using basically the same syntax here. So I could rewrite this loop right, where I have my numbers array, and I can place that in my for each loop. So this is the array, is numbers, and then I set up a variable, right, just like I do up here, to load the current memory position that we're looking at in that array. It'll start at position 0 and it'll go automatically through the structure one at a time. And a real common naming convention for this is to use the singular form of the plural form of the array. So like when you're naming your arrays, it's really common if it holds a collection of numbers to name it with a plural. And then when I do a for each loop, I use the singular word to traverse the structure one at a time, right? So what we're saying here is for each number inside the numbers array, I'm going to go through and I'm going to do this process, and it will traverse automatically. So this is very, very useful, particularly when you are reading information in from a data structure and then doing something with it, right? It will start at position 0. That was what I was mentioning, and it'll go to the index, the highest index value -1 automatically without me having to probe its length or remember how big it is, right? So kind of cool, right? It makes it a lot easier to traverse that structure. Okay, but there's a however. Here's the howevers, and it's a list of howevers, right? If you're using a for each loop, you can't use the for each loop to change the contents of the array, but you can use it to access the contents of the array. So sometimes when you're data processing, that's all you really want to do is just you want to look at the data and then do some math with it or do some output with it. You also can't work in reverse order. So I can't set up the for loop to start at the highest index and go backwards. But you know what? With a regular for loop, I can engineer it to go backwards, right? So if you like, hey, give me all those numbers backwards. Okay, a regular for loop can do it. For each cannot. I also can't skip any indexes except for it says just evens or every third one or whatever. I can't do that either. It has to take the indexes in order, where if I did like a regular for loop, I could change the increment here to be like I plus 5, take every fifth one or whatever, cannot do that with a for each. And because it operates automatically, it's not really working off the index or the subscript. It's just traversing it manually, mechanically, if you will, in memory. And we can't use that value then, like even when we did the donations thing, like here, we were using that, that counter to do math. So I can't do that because it doesn't exist in the for each loop. So those are the limitations. But if you're just reading in information and processing it, for each loops are wonderful, right? Because you don't have to do the mechanics of the for loop to really make it work correctly. All right. Kind of an interesting thing happens. Like let's say you have your array and then you're like, you know what? I don't need it to be this big. I want to make it from size 10. I want to shrink it down to size 5 because I realize I don't need those other 5 positions. You can do that. Here's the syntax for it. So I just create it of the size I need. I might do a whole bunch of stuff with it in my code. And then later on, I'm like, well, now I can shrink it to a smaller size. I don't want to change its name. I just want to change its size. And so you do this. So it basically creates a new integer array, in this case, of size 5. But what happens to the stuff that was in there already? Well, it's gone. Sorry, but you just deleted it all, because we're starting with a fresh array. And then whatever was removed is what is garbage collected. And there's this whole concept of garbage collection. I think I may have kind of mentioned it a little bit to you. If you click on the link in the slideshow, you can get to this page. But garbage collection is this weird thing. And I may have mentioned it to you guys. Like when I first learned how to code in the C programming language when I was in college, we would have to create variables and then we would have to destroy the variables, and I forget what the command was for it, but it's like the memory wouldn't release back to your computer system for whatever you had stored there unless you told it to release it back. So even if the program was done running, that memory was occupied. So it was conceivable that if you didn't do your own garbage collection or get rid of stuff and destroy it, that you can fill up your computer memory and then nothing runs. Not what users like out of their computer programs, by the way, right? And garbage collection these days in modern languages happens automatically, and that's kind of the point, right? And that's why we have a little picture of the garbage truck here, is to kind of make that point clear. So if I take that array and rebuild it to a new size using the code that you see here, the original one is gone, and just picture it going into the garbage truck and going to the landfill, and it's never coming back, right? So garbage collection, right, is this process of freeing up memory after you've removed something from it. All right. One other interesting aspects of array, just like other types of variables, is we can move them around a program as an argument or a parameter for a function. And basically, it's a complex data object, right? But we can still move it around. So I can send it to a function for processing, do stuff to it, and then send it back. That's entirely feasible. So in this case, if I want to send an array to a function, I use the naming convention for declaring it. So just add the square brackets after the int, or if it's a string, or if it's a character or a float or a double or whatever it is, right? Whatever that data type is, plus the square brackets, and then the thing that you're sending in is the whole structure to be processed. And then whatever the function does, like in this case, it multiplies everything by 2 and then puts it back into the array. That's what this does, right? When you also send arrays off to be processed, you can process them, and then send one back. So you can return an array, and then notice that the return type is declared in the same way we declare it to create it, with square brackets after the name. So when you create a function that returns a value, the very first expression is what you're returning, right? This indicates an array of type double. Okay. All right. So I have a little programming prompt here, and this is kind of an interesting one. It says, write a true false quiz with 3 questions. Use 2 arrays, one with the questions and one with the correct answers. All right. And then you can prompt and ask, and I do have this pre-built. So here's what I'm going to do is I'm just going to kind of put it up on screen really quick. You guys don't have to code along with me on this one if you don't want to, but I just want to show you the concepts so that, if you're curious about how that might work. Because so far, let's think about this. We've worked with arrays that are holding numbers. We haven't worked with words or characters yet, have we? Right. But I do want to show you that it's absolutely possible to do that. Now I'm going to kind of be kind of silly here because I don't want to destroy my old code. So I'm going to put all of this inside of a comment mark, the CSS style / star and then star / and then I'm going to write my new code down here. And I do have this pre-created here on the other screen, so I am just going to do a bunch of copy pasting. And the first thing I'll do is I'll create an array of type string. Now check out how I'm doing this, right? And I'll do a little indenting here. And string is just a data type for us, right? So I put the square brackets after it. I'll call these the questions. And notice they're just strings separated by commas, right? Inside a set of curly brackets. So what I'm doing here is I'm creating the array and populating it with content. Because the sentences are long, I'm just putting each one on a separate line. But I'm brute force creating the construct. What size is it? Well, it's size 3, right? If I ran the length function of it. Then I can have an array with the correct answers. So for example, here's an array of characters with true, false added to it, right? And notice once again, I'm hard coding it in. I'm pre-declaring the values and sizing the array. There's 3 questions, there's 3 answers, and in principle, this relates to that question, this relates to that question, and this relates to that question. Now, if I were to really turn this into a quiz, I might do something of this nature. I might create an integer variable to hold the score, right? And then I might come up with a for loop, kind of like this one, right? Where I'm going to traverse the question structure. Notice it's going to run up until the length of the questions. And then it's going to read the question from the array, put it on the screen. Then it's going to wait for the answer, right? Notice like the little things that were added here. What does trim do? It removes leading and trailing spaces. What does upper do? Well, it changes it to uppercase because I'm asking for true, false, TF, but they might type lowercase, right? They might be on a phone or something, who knows? And then basically if it's correct, we're going to add to the score. But if you check the if statement here, we also make sure that they're not typing too many characters. We just want one character, right? And we also want to check to make sure that the input that we're grabbing is the same as the answer that we're grabbing, right? And that's basically the whole program. It's a pretty simple little thing. And then I have a little extra statement here just to check to see how many we answered correctly. All right. But I just want to show you that you can do this with strings and you can do it with characters as well. And I'm just going to run this really quick just to show you how it works. Right. Hopefully that it works. Right. Is Australia wider than the moon? And we'll say true. I'm not even sure the correct answers, even though they're right there on the screen. So I'm going to answer one of them wrong on purpose, right? Very, very simple. But I'm hoping that what this shows you is that we don't have to just work with numbers, right? And if we have the content in advance, we can hard code it in there. And we can create lots of really creative things that way with these data structures, right? So instead of like worrying about like, well, this could be one variable, this could be another variable, another variable, another variable, another variable, we can combine those. And then of course, if I wanted to ramp this up, I could have 100 questions and 100 answers. And then of course, we'll learn later that there's even more efficient ways to do this. But for now, this is an example of the try it at this point. Right. As we start to work with arrays, we start to figure out that there's a bunch of different array algorithms that we can use that become very, very useful. This is really a weird one though. Okay, so if I take an array and notice I'm hard coding values into it, some even numbers, and then I create another array and I say that array 2 is equal to array 1, this doesn't actually make a copy of the array. This is a really weird programming idea. What I'm really doing is I'm creating another array that refers to the same array in memory. This is really bizarre. This is called, copying by reference is really technically what it is. So if I change something in array 2, right, and we haven't learned how to do that yet, it will also change it in array 1. If I delete something in array 1, it also deletes it in array 2 because why? They're both pointing to the same array actually. So if I do this syntax where it looks like I'm creating a copy, now I have a new array. You do not have a new array. You have the same array with a different name. You just have 2 names for the same array is what you have. There are times where this is useful, right? I'm going to say mostly for
think of it as an alias.
Sure, you could, Bob. I don't think that's a bad way to think about it. It could be an alias. So, like, if you have a better way to refer to the same thing, but really you're dealing with the same stuff, right? Yeah. So, I think an alias is a really good way to think of it. Right. Um, Now, if I did want to create a new array, all right, we have to use the new keyword in there to create it, right? So I have array one, same one as before. Now I'm creating a new array with 5 spots in it. So I have to use the new keyword, but notice the new array is empty, doesn't have anything in there yet. And then if I want to actually copy the array, we use a method to do it, or function, right? And basically the parameters are, I'm going to take array one, copy it into array two, right? And how much of it do you want to copy? So the length becomes an aspect of it. Now think about this, because if I have one array that's of size 20, and then I have another array that's of size 5, I probably want to cap it so that I don't overflow, right? So if I'm copying from one of size 20, I'm going to say, well, array one length is 5, so only copy 5 of those, right? In this case, they're both the same size, but what if they were different sizes? That's kind of the point. So if you truly want to make a copy of the information, you have to create the array first and then copy the information into it. The copy command, if you think about what it does, right, and this is really kind of an interesting thought, is it basically runs loops that traverse the one array and then reads one value at a time and writes it into the corresponding position in the other array. So the copy method saves us from writing those loops. That's really what it does, right? All right. You can also use the what we call the copy to method, right? It's very similar. And then it says the number is the index to begin copying from. So if I want to copy to array 2, and then I want to start at position 0, right, which is the first position, that's where I'm going to start from, and then it'll proceed, right? So maybe I want to start at a certain position and go to a certain position. That is the copy to command. So that's helpful. We also have some other methods available, which are kind of interesting too. So let's say we have an array of students and an array of teachers, right? You notice we have the same people in there, right? And then if we go through, we can actually check to see if the arrays are equivalent. So I can just do like the standard, like I'm comparing two variables, and it'll just look at all the data inside the structure and see if all the positions match up. And if they do, they're the same. If not, they're different, right? So that actually works. That's kind of weird, right? So you can actually do that. That's kind of I'd say a weird use case scenario, but sometimes it is a thing, right? And Steve, maybe we go back to your hardware checking example, kind of thing. Are these the same, to see if there's any errors? And what's interesting about this, right, is this double equal sign when we're comparing objects, and this is kind of an important concept again. It really are what we're really asking is if the variables contain the same memory address. Okay, that's weird. So this is the reference thing coming back now, right? And so what we're really saying is, does address A equal address B? And that's not really what we're asking for, right? If you think about it, because what if they did have different information and then they're not, if they're referring to the same memory address, of course it's going to come back as, yeah, it's the same, because you're pointing to the same object. So really what we have to think about, right? And the point of this slide is really kind of like the how you say the question, right? And what we're really meaning to ask is do these two different arrays contain the same values? And then there's a different method for that, which is called sequence equal method, right? And so if you go to the next slide here, this is where it kind of makes a little more sense. Here we truly have two different arrays. They happen to have the same values. And then if I use this method, sequence equals, then I can actually check to see, are they really two separate arrays containing the same exact content, right? And there are times where this might be something pertinent to do. Can't think of an example in my head right now. As you might suspect, and so Caleb, here we go back to like totaling things again, right? Where yeah, I could create a variable, do the math, and then store it. But you know what? They also have a method where if we're storing numbers, I can run the sum number or method, excuse me, on that structure. So here we have an array called values. I'm adding the sum method, chaining it to that object, and then that will return a value that we can then store in a different variable. But once again, we're storing it in a different variable, right? But we don't have to write an equation that says, well, okay, let's go to position 0, add that to position 2, to position 5, whatever, and add them all together and do the math mechanically like I did before. If you remember, this would just total everything in there, whether it's one number, 10 numbers, 10,000 numbers, it would just work. Right, so that would do all that processing, and I think that's pretty interesting. Of course, if you wanted to calculate the average of all the numbers inside of there, well, then you do have to do a little bit of math, right? But that's doable, right? So if we took the total from this slide and then divide it by the length of the array, well, that's going to give us the average. There's also min and max functions that we can apply to arrays. So this can be very helpful. Obviously, when it's a very small list of numbers like this, I can just look at it and tell you what the min and max is, not a problem. But if it's a list of 10,000 numbers and it's pages long, these are very useful functions. So like, what's the biggest number in the array? What's the smallest number in the array? Very useful, for sure. Arrays can also be sorted, right? So this is another neat feature of them, is that I can take an array that's got values in it, and then I can run the sort command, and then that will put the values, if they're numbers, into a sort order. Question you might have in your head is, does that work with strings? Well, given what we know about strings and that strings and characters have Unicode values behind them, well, in principle, it could work with that too, right? Because they can be sorted numerically, and that's how the sorting works, by the way. All right. Let's talk about this concept of what we call parallel arrays. And this is kind of a useful approach as well. So when you have, it says here, two separate arrays that contain data that's related, right? And so like, when you start to think about this, you know, your head should go to like a spreadsheet, right? And I don't know how many of you are like spreadsheet people, you know, but you know, arguably one of the more important like the software products and data structures is what we call tabular information, rows and columns of information. So it's not unusual, for example, to have arrays that are synchronous in size, and the positions in the arrays contain synchronous information. So for example, on Monday, it's intro to C#. On Tuesday, it's intro to SQL. On Wednesday, right? So you see like there's correlations. And then on Friday, thank God I have off, right? And that's not always true, but sometimes it is true, right? Now, if I have two arrays and the intent is to kind of sync this information together, as it says here, it's up to the programmer to understand that, you know, position 0 here correlates to position 0 here. That's the thing, right? The language or the language engine doesn't really know that they're related. It's us, the programmers, that know that they're related, right? So here's kind of an interesting thing. If I take arrays and I want to sort them in parallel, this is kind of a weird concept. I can take each one of them, send them to the sort method, and then the second array can, in principle, sync with it, right? So in other words, if I like take my class list and then say, okay, well, let's sort it by something else and then change it to have the second array automatically comply with the same sort, right? And this is the thing that always perplexed me, like when I worked in spreadsheets at first, and I would have these big tables of information, and then I would sort a column, and I would go to myself, what about the other stuff? Is it just sorting the first column, or is it sorting all the stuff that went with it, in that row to follow it? If you guys have ever done sorting in a spreadsheet, you know what I'm talking about. Um, so this is kind of the thought. So if you take a look at this little table here, right? We're thinking that Aaron goes with 3.75, Jose 3.9, and Alicia is 3.81. And so if I do this command, and notice I'm sorting first with the students, but I want the GPAs to follow. This is the syntax. So I can feed it in that way. And then those arrays, even though they're two different data structures, will be treated as if the positions in each are synchronous. So if I sort the students, the GPA positions will also adjust to the same thing. So this is kind of an interesting thought, right? That we could actually do this command and it does work that way, right? If I wanted to do the flip, if I wanted to sort by GPA, let's say lowest to highest or highest to lowest, I could do it the other way around. I could use GPAs as the priority and then students would follow, right? There is a try it out for this. And I don't know if I have an example on this, and maybe it says create a cybersecurity program that tracks the number of intrusions detected each day of the week. Prompt the user to enter each day's count. All right. And then there's going to be kind of a ramp up to that. All right. Well, I can, I'm looking over here and I think I do have that sort of written here. So what I'm going to do is I'm going to do this comment out of my old code here again. And then I'm just going to kind of code through this. So, all right, looking once again at the prompt, if I want them to enter the number of intrusions for each day, I think it makes sense to create an array that contains the 5 days of the week. How about we start with that? So back here in Visual Studio, what I would do is something like this. Is I would create an array of strings with the days of the week. And if you guys are trying this, here it is in the chat, by the way. Save you the typing. And then I'm going to add a couple more snippets here. All right, notice what I did is I created an integer array, right? That's going to store the number of incursions or intrusions or whatever they're calling it. I don't know what those are yet, but I'm making it a size 5. What's stored inside the array when I do that? The number 0, because it's a number, right? Then we'll also have a total because we're going to keep track of that, right? All right. So last time I tried to make it look kind of fancy, so I did a little header here, right? A number of intrusions, and I'll just give you guys all the code if you want to just paste it in and try it. By the way. All right. Next thing that we would do is we would ask them one day at a time, okay, let's put the day up on the screen and then type in the number of intrusions and then the next day, the next day, the next day, the next day. And so for that, I created a loop. And here's the loop. Right. Once again, in the chat, if you want to try it. Right. So I'm going to run the loop. Notice until I is less than 5, right? We'll put the day of the week up. It's going to read each index position one at a time. So we'll say Monday, then Tuesday, and Thursday. And then they'll just have a prompt where they type in a number. We're going to capture that and then store it in the corresponding position in that array, right? If I want to count the total, right, or add to the total, I could just uncomment this line here, and that will just total it up. And then ultimately, we would just output that to the screen. And we would just do that down here. Right. Very, very simple little program. Right. And so if you run that, and the intent, of course, and I'm giving you the code so you can try it for yourself, or have this as a model for other code. So let's just, type in a variety of numbers here. And hopefully these aren't the actual intrusions, right? That's a lot of intrusions, but you would be surprised sometime if you ever work cybersecurity to see how many attacks happen on a daily basis on some systems. It's pretty astounding, actually. Um, what I often tell my students is there's this quiet little cyber war happening right now between, like, you know, let's say like China and North Korea and the US and other entities, where they're always attacking each other. And another really interesting aspect of that is, and I think the war in Ukraine kind of brought it to the light a little bit. Like before they ever started fighting on the ground in Ukraine, what was the first thing they did? They had these huge cyber attacks from both sides. They were attacking each other's infrastructure and systems and trying to bring stuff down. Because if you can take a power plant down or knock a utility offline or whatever, right, you can disrupt things, then it leaves the door open for military attack. All right, so that's an example, right, of kind of doing that. And these are, think about this, these are parallel arrays, right? So if I wanted, for example, to sort things, I could do that. Now, I think the next slide, if I'm not mistaken, it's been a while since I've done this, about a year, I guess. All right, so it says once the data is entered, list the days and the number of intrusions, the total intrusions for the week, average intrusions, highest, lowest, and then use the two arrays, one to store the names of the days, one to store the names of the intrusions. Okay, so we kind of did that part already, but like these extra tasks, I do have the code pre-written, so I'm just gonna kind of dump it all at once. And I know that might be a little bit overwhelming to have it all at once, but I'll give it to you. You can play with it. And then you can utilize it for your own purposes later, by the way. But I'm going to also add that code here. So we did those tasks that they asked initially. But if I wanted to do this and then get the sum, okay, so I can use the sum function or method, excuse me, right? If I want to get the average, well, I can take the length of one of those arrays and then divide it by the sum, right, to get the average, right? Pretty common sense stuff. And then we can output that to the screen. Min and max are pretty easy to use. So I can just look at the intrusions and figure out which, is the min and max. And if I was smart about it, I could also, correlate that to the day. We can sort them. So here's an example of sorting the number of intrusions by the days, and then actually outputting which had the most and which had the least. Right. And apparently here I hard coded that last time, but you could also determine that if you wish. Let's just go ahead and run it. And just so you can see how it works. So we had one on Monday. Right, and there's an example of all the output that goes with, and just moving it over here so you can still kind of see the code as well. So just playing with all of those methods, just getting your hands in and kind of touching it. And now, all right, so why is it I hard coded these values is really kind of one of the questions. And this is kind of interesting because if you looked at how I typed it in, I made sure that position 0 was the smallest and then position 4 was the biggest. You guys catch that? All right. But what if I didn't do that? All right. So, and this is kind of the point of the sort, right? What if I was a little bit more random with it? And okay, so which is the least and which is the most? Well, the most is Wednesday and the least is Thursday. So those are positions 0, 1, 2, and position 2 and 3 are most and least, right? So why then does my code still work here? Because I'm sorting it first. So I'm sorting by the number of intrusions. The days get sorted with it. And then if I sort them, right, the day with the most gets moved to that position number 4, and the one with the least gets moved to position 0 via the sort. The sort goes ascending, smallest to biggest. So that code will always work regardless of the order that I put the stuff into. So this is, real basic logic, right? But kind of useful stuff for sure. All right, let's keep moving on, folks. All right. So we've learned about arrays. We learned that arrays can sometimes be parallel and we can have them kind of work together, they sorted together and arranged together. But arrays are kind of interesting because we can get into what we call generally multi-dimensional arrays. And this gets a little bit weird, right? But when you think about an Excel spreadsheet, right, which basically rows and columns, isn't that really an array of arrays, right? So each array position contains an array itself. And then when you start doing that, I mean, really you're forming what we call a tabular structure. So really a spreadsheet structure is a two-dimensional array, meaning for every array position, we have another array within it. But more importantly, those array structures are synchronous, at least in their size, right? And it says so far we made one-dimensional arrays like a table with one row. Arrays can be of any data type, including an array of arrays, right? So I mentioned that before, like a table with multiple rows, right? So if you wanted to create a two-dimensional array, you can actually do that directly with just the syntax of the language. And this is, I think, pretty interesting that C# allows for this, by the way. So the way that we do that is when we do the declaration of the array, we include a comma here in the declaration. And then when we use the new keyword, we indicate how many rows and columns. It's rows and columns is the order, by the way. And if your brain thinks columns and rows, you have to flip that, to make the syntax work. But this would create 2 rows with 3 columns, right? And so if you looked at it as a structure, right, and this is what it would look like. But what this is also indicating to you is if you wish, instead of using the new keyword and declaring the size of the rows and columns, you can also hard code it like this. So notice what I'm doing is like normally when I do an array structure and I want to hard code it, I use the curly brackets. And then in each array position, I'm placing another array and then separating it with a comma. But here's the first row, here's the second row. This is a column, that's a column, that's a column, right? Now, if you think about like how you store information in a spreadsheet, okay, this is pretty useful, right? It's very, very common to extract data from a tabular format because that's how databases store information, right? And a lot of data in spreadsheets is stored the same way. So if you have like tables of numbers, it's conceivable that you can easily convert them to two-dimensional arrays in a programming language and then use the programming language to crunch the numbers or arrange the numbers or do whatever with the numbers, right? Like you would in the spreadsheet. And it kind of gives you an idea of like, oh, so that's how a spreadsheet works. Like you're starting to see like maybe a little bit of the secret sauce of like why spreadsheets are so magical, really. If you're going to do some processing on a two-dimensional array, you can, for example, refer to particular spots in the two-dimensional array using a combination of the index numbers. So now you're not dealing with just one index number, but you're dealing with the row and column numbers. So if I wanted to access the score, or if I wanted to put the number 29.75 in position 01, that would end up here, right? And then I can access any of the other positions in this structure conceptually using that same syntax, provided I understand where it's going. So I can store stuff there. I can extract stuff from there. I can change that information just using this very simple syntax. I mean, it is still truly is just a single variable that we're affecting. It just happens to be in a slightly more complicated data structure. Mind you, this is a two-dimensional array. All right, you want to blow your mind, right? What happens if inside that array position I put another array, right? Then we get to a three-dimensional array. That gets really weird, right? Two-dimensional is very, very normal because once again, it simulates a spreadsheet. And that's kind of the whole point of it. So very, very useful because we store a lot of data and information in spreadsheets. One suggestion they give here is the fact that when you're declaring a two-dimensional array, it's not a bad idea to very simply use variables, and really, in this case, they're actually using constants to set up the rows and columns, right? And the thinking here is, if you're using this structure over and over again, it's declared once and you could just change these at some point and change the structure, right? I'm not sure I really see much of a functional difference on that, because think about this. Once you create an array structure, its size is fixed anyhow. So whether you hard code it or put it in a constant, not much of a difference, right? All right, so if I can use a regular loop, like a for loop, to access all the stuff in an array, how do I access all the stuff in a two-dimensional array? Well, the answer is you use nested loops. So I put one loop inside the other, right? So the one loop deals with one level of the table and the other one deals with the individual contents of, like, one row, for example. So here's an example. If I ran one for loop, so one would access the row. So the outer loop would traverse the row. So in other words, let's start at the first row. Then once we're on that first row, we'll go column by column, grab the information, output it to the screen, whatever we're doing, right? Then I'll put a blank line, and then we'll move on to the next row in the loop, and then go column by column, writing out the scores, type in a blank line, go to the next row. You just repeat the process. But you see how that works, right? Because the structure is ordered, we can use a loop inside of a loop to traverse it very, very elegantly and powerfully. Now, the question they asked on the previous slide is, can you use a for each loop, to do this? And the answer is yes. And this is really kind of weird, but if scores is a two-dimensional array, a for each loop, and this is where it's really super powerful, mind you, I don't have to write a loop inside of a loop. The for each loop would automatically traverse that complicated structure row by row, column by column. Right. One row at a time, each column, one row at a time, each column. And for each would do it automatically. Now think of how much code that saves you, and what's easier to write. Is this easier to write, or is that easier to write? Yeah, way easier to write, All right. We're at a logical stopping point here, so let's take another 5-minute break or so. We'll pause the video here for a moment, and let's come back at around, let's say, 9:02. So I'll see you guys in about 6-7 minutes. All right, welcome back. We're going to now move forward, and we're going to talk about some additional collection types. The first thing I think that's important is to talk about the fact that C# does not only have arrays available, it has all of these different types of what we call collections, which are all basically named objects that can hold multiple values. All of them have different types of capabilities. Some of them kind of cross-populate a little bit. And I would say that the two that are at the bottom are typically a little bit more complicated data types in terms of how they operate. Um, Not really that hard to learn, but they're used in specialty situations. The ones that were the two others that we're going to look at here tonight are lists and dictionaries. And let's start by talking about lists, and we'll talk about like kind of like what how they're similar to arrays, right? Like an array, it does use one singular name to hold multiple values, right? And there is a data type, right? So like I can make a list, for example, here of integers, and notice once again we do have the new keyword. We use angle brackets instead of square brackets, and then at the end we have the parentheses, which makes this basically the constructor function for this type of object. But that all of that's required when you uh, build it. And regardless of the data type you put in here, like an array, it holds multiple values, right? In this case, I want you to notice that we're not putting a number over here. We're not saying like it should be size 5. We're not doing that, right? It sizes dynamically. So in other words, we can create it, leave it empty, and then add stuff to it. And as we add stuff to it, it gets bigger. How big can it get? Well, how big do you need it? And this is one of the problems we have in programming. So why do they develop lists? Because sometimes we don't know how big something's going to be. We don't know how many times, let's say if you're capturing user information, how many times that user is going to enter that information. It's unknown, right? Might be 5 times, might be 1,000 times. Depends on the user, obviously. So as we start to add elements, we actually have a method in a list to add it, right? So what we do is we just add a value. So all of these are integers. So we just say my list add. What are we adding? That number 5 goes into the first position. Number 4 goes into the second, etc. And if you're guessing like, well, if I'm going to extract that information out of there, do you use the same index numbers? The answer is yes. You use the same index numbering approach to access the contents of a list. Now, those of you, once again, I make the correlation to Python because I know that's a big language here at this school, right? And a language that some people learned before they learned this one. This is a lot more like a Python list, where like in a Python list, you can make it as big or as small as you want. You don't have to declare its size. You can create an empty and then add stuff to it later, right? So this list kind of works the same way. The difference here is though, in Python, the lists are not strongly typed, meaning I can throw in a string and then throw in an integer, then put in the floating point number. Like you put in whatever you want. Here in C#, it is strongly typed. So you do have to stick with your data type when you're doing that. They do have an approach here that if you want to hard code the values right into your list right off the bat, you can do that too, right? So you still use the new keyword, but notice the parentheses are gone here, right? And you just put in a set of curly brackets with your comma separated values. And now we have a new list of strings with these values inside of it. Pretty cool, right? So there's a way to just force stuff in there if you wish. And if by some chance, like you think you're working with Python and you try to throw a string in there when you know it's not going to take it, it's going to fail. So if I try to put this in there, not going to work. Also, because it's an integer list, the floating point number won't work either, right? So those are off the table, right? And it will throw an error, right? Once again, C# is strongly typed. So if you declare a list of a certain type, that's what goes in there. When it comes to accessing the items inside there, right? So you can see right here, for example, if I want to access any one of the colors in any given position, I still use an index value to do it. So position 0, position 1, position 2, position 3. So index 0, 1, 2, 3. Still use square brackets for that though. So no change there. The change is really in how you declare it with those angle brackets, but accessing the information And doing that is pretty simple, just using those square brackets. You can also iterate through it, right? So you can use a loop on top of it for each loop's work, right? So notice though when you do this, they're using var, right? Just in case you don't know like the data type of what you're building. And I'm not really a fan of using var. I always like using the data type that we're using. Of course, this would dynamically adjust and realize it's a string, and that var really does become a string at some point. But if you're processing it and you don't know the data type, you use var as a safety, basically, is kind of the purpose of it. But it is capable of using a for each loop to iterate through. And if you can use a for each loop, you can easily imagine you can use a regular for loop as well, which we saw on the previous slide here, right? The regular for loop works, a for each loop works as well. If I want to add an element to a list, well, we saw that we can use add, but if I want to drop a value in at a certain position, so right now red's in position 0, blue position 1, green 2, pink 3. With this insert command, notice I can choose the position and the value that I'm inserting. So this would insert cyan at position 2, 0, 1, 2. So it's going to put cyan here, and then these two will shift over. So cyan becomes position 2, and then green and pink get shifted over. So that's one thing I can do here. And think about this, because the list is dynamically sized, I can do that. And this is very powerful. So I can insert something into a specific spot just because I need it there, right? To do some sort of ordering or something or whatever. We can also remove stuff. And there's a couple different commands here for that. So I can remove something at a given position. So you use remove at. And so that would go to position 2, right? 0, 1, 2. So this would remove green. And then otherwise, if I know what stuff is inside my list, I can just call it out by name and say, go find blue and get rid of it. And so both of those with those two statements can remove. So now notice that, like, how convenient this is though. Like if you don't want to think about index numbers, but hey, I know there's a color in there named blue, I can go in there and remove that just because I know what it's named. Right. So that's very, very handy, by the way. Now, keep in mind, if you don't know what's in there, well, you can print out the contents of the screen and take a look and go, oh, there it is, right? And then you can, remove it later. Another thing that's kind of neat that you can do here is you can use the contains method, which basically checks to see, all right, well, here's another way. You don't have to print it out to the screen. I can go, hey, does this contain red? Right, so I could write an if statement. So in other words, contains over a list object, when I'm looking for a certain value, this will return true or false, right? So I can put it in an if statement, and if it contains red, well, then I can say it's got red in there. Okay. Notice here the not operator. So that we're saying contains white or does not contain white, actually. And then I can test for that too. So kind of handy, right? Cool, simple little methods. So we have add, remove at, we have insert, and contains. Very easy to use. But you notice how similar this is, to working, basically with arrays. It's not really that much different. It's just how we declare it. I think what's kind of helpful here, and I do have a little example that we can play with. And so I'm going to come back over here to Visual Studio. I'm going to comment out the code I created. And once again, I will share the code, so I'll just drop it in the chat for you guys. But I'll begin by creating a new list. So here it is in the chat. Here's the declaration. And then I'll drop it here in my code as well. Paste that in. So I'm just going to make a list. We'll just put integers in it, and notice the new list int and then parentheses here at the end. And then if I want to put stuff inside of it, I can just use a series of add commands. Very similar to what we did or saw in the slides, I should say. So you can add a bunch of values. So that would add values in there. Once again, this will go position 0, position 1, position 2, position 3, position 4. Its size is 5. Right. If I want to iterate through this and see what's in there, okay, well, I can use a for loop for that. So here's the for loop. In fact, we can try it at this point because we have some way to put it back up on the screen. So if I run this, there it is. It's just iterating out those values, and I'll zoom in so they kind of match up in size a little bit. And notice we're using the count property here to count the size, right, to run the loop correctly. Could I use a for each? Yep, I could use a for each there too. I didn't, but I could. If I wanted to create a list of strings, kind of like the same colors we're seeing in the examples, and I'm going to indent all this, by the way. And yes, I will pop that in the chat. Guess where I grabbed that one from, right from the slides. And so there's the structure. So this one is, instead of adding the stuff, we're hard coding it right from the beginning. And then once again, if I want to output that to the screen, I can use a for loop to do that. And you can run that right away and then see the output. Of course, if you want to try it with a for each loop, it's not really that hard to do. And I'm sure you guys can probably figure that out just based on the examples. But very easy structure to work with. And of course, if you want, like if you wanted to just play with the methods that come with it, you can do that as well. So like one thing you might want to do, right? Like you could simulate, for example, the same thing they did in the slides, right? Remove at position 2 and remove blue, right? And then once again, you would want to output the structure to see the change. So I just run it all at once, and this is going to not look great. But notice that, all right, we did the numbers. Here's red, blue, green, pink. And then we removed at position 2, which was green. And then we removed blue. So we removed those 2. So then when it did the output again, it was just red and pink. Right, just to show you that it works. But very easy. Like you can take the examples in those slides if you're not sure how something works, copy it into your coding engine, run it, play with it a little bit, see how it works. Right, very simple to do. But you notice, like once you get kind of how the one data structure works or collection type works, then you move to a different one. It's just learning the different techniques to operate with it. I do like lists quite a bit, and I guess I've gotten used to them by working in Python, where that's kind of like the go-to structure. They don't have an array structure in Python. That's like of a fixed size and a fixed data type. Python is like, you want to put it in there? That's fine. That works. You want it bigger? That's fine. You want it smaller? You want it to go away? You know, all those things apply in Python. So I really kind of dig that. You know, if I'm building stuff from scratch and I want it to be as flexible as it is in Python, list is kind of where I go, but it doesn't have the flexibility of the data type like Python does. Right, so be mindful of that. Another really important data structure is this concept of a dictionary. This is the same thing we call it in Python. So if you've learned that concept in Python, if you're comparing it to other languages, for example, if you know PHP or Java, we call this an associative array in those languages. In JavaScript, we tend to call this, key value pair or JSON object. And you'll see some correlations here, although the syntax in C# isn't quite the same thing. But this is a really kind of interesting thought, right? So when we declare a dictionary, I want you to notice that instead of using one data type here, we're declaring 2. The first one is the data type of the key. The second one is the data type of the value being stored. A really good correlation here, right? And the reason they call it a dictionary is think of how a dictionary works. You pick up a dictionary, you flip through it, and what are you looking for? You're looking for a word. The word is the key, right? So I'm looking for the word dictionary in the dictionary. I find the word dictionary, and then next to it is the value or the meaning or the definition of that word, including how to say it. And then, it's like this is how it's used and whatever. But the value is the information that's provided next to it. But the lookup or the key is the word itself. In this case, what they're setting up is a dictionary of days where the number 1 represents Sunday, 2 represents Monday, and they're different data types, but that's okay. The key can be any data type that's valid, and the value can be any data type that's valid. In this example, it just happens to be an integer and a string, right? Now, what's interesting about this data structure, it doesn't have an index. We don't go position 0, position 1, position 2. The numbers that we're putting here are just accidental, right? But we do have the keys which operate as the index value. So we don't look things up by their index value. And this is kind of weird, right? But this is how we do it. Notice that the dictionary structure is built with that combination statement. So key value pair, that think of that in your head, right? And then when you do the new, it kind of works like a list with the parentheses at the end. Both of those data types are indicated here as well. And then if you want to add entries, you use the add method to do it. Interestingly, you can add stuff seemingly with it seems to be an index number, but if the key was a string, you would put the string here instead of the number. In this case, they're using the number to kind of make it seem like it's an index value, but it's really not. That is just a unique value. So that number could be 44 and it would still be valid. That's just the lookup, that you're using to find the word Wednesday, So very kind of interesting data type. What's interesting about this collection type is that if you set it up correctly, the information is kind of correlated. It's kind of like having like columns in like a database table, right? Where the key tells you what type of information is stored in the value. So for example, if I had like a string and a string, maybe the first string could be first name and then it's John, and then last name Smith, and then address 123 Elm Street, for example. And then if you're looking up the address, you ask for the address and it gives you the address. That this is kind of the correlation. If you want to think about it, like the card catalog at a library, right? And what are you looking up? You're looking up the subject, the title, or the author. So each one of those has its own key that you use to look up the value that you're trying to find, right? So once again, kind of hammer this point, right? If you're using one thing as the key, basically as a replacement for the index number, well, that key's got to be unique. That's the one thing about why we use index numbers is they automatically increment. So they go from 0, 1, 2, 3, and they just keep going for as high as you need them. But just by virtue of the fact that they're incrementing mathematically, they're unique. So if you're creating key value pairs where you're in control of what the key is, you have to make sure that it's unique. If you try to put that key in, it will, and it's not unique, it will fail, right? So the keys must be unique, kind of like the ID field in a database table, if you will, right? If you guys are learning that stuff as well. So, well, fascinatingly, like here, they're just taking the key, which happens to be a number, right? And they're saving it as a variable. So you can use a variable to feed the key value, right? But that's the lookup. If I go to that data structure and go and look up the key number two, what's really stored there, the value is Monday. So inside here is that's what gets stored is the value of Monday. And how do we know that? Well, here's the key and here's the value. So that's kind of how that works. Now, once again, just because we have key value pairs does not mean that we can't use it to do the same kind of stuff that we do with the other data structures. For example, to traverse the structure and extract information. This is kind of interesting though, because it is structured a little bit differently. And notice what we have to do here is when we do the for each loop, right? We set up, we basically say the key value pair. That is a type of object, and we indicate that, okay, well, the key value pair, the keys are ints, and then the values are strings. But please do remember this, that these can be of any data type. This is just an example, right? And then that would be for any entry in the day's data structure. And you can both access the key value if you want to see it and the value. So you can use both pieces of information. So each storage position has two pieces of information, the lookup and the value. And both can be used to do stuff, right? So depending on like how you do it, you can be really, really crafty with this and use it to do a lot of different things, right? And it really explains part of its popularity, like in this, JavaScript object notation or JSON data transmission format. All right. So if you wanted to kind of skip this approach of doing this whole key value pair thing in a for each loop, you can just use the var keyword here, and that will automatically give you the key value pair, so you can still extract both. It'll adjust. It'll say, oh, what is days? Oh, it's a dictionary, so it's got key value pairs. So this must be key value pairs. It'll automatically adjust. So a lot of programmers do use this for dictionaries. Dictionaries do allow for direct initialization of hard-coded data or literal values. And here's an example of how you do that. Kind of like when you do a two-dimensional array in a way, right? And you can kind of think of it that way, right? Because this type of data structure is often used to extract information from a database where this might be the column name and this might be the value stored in that column for that particular individual or entity. So this is an approach for populating a dictionary as well. If you want to check to see if an entry is in the dictionary, you can actually run the contains key method. So you can check and say, hey, is there a key? Is this key inside the dictionary? And if so, we can extract the information. Otherwise, if it's not there, you can kind of omit it. But that's a possible way to access the information. All right, so there's a little try it out here. We'll do this, and then we'll field any questions that we might have. And then I think we'll probably call it a night after that. We'll try to end a little bit early tonight, which I think you guys will appreciate after all this like lecture stuff, right? So, all right, it says create a letter counter, right? Ask the user for a word or phrase. Use a dictionary to count how many times each letter occurs in the input. And there's a hint here. It says the key is the data type character and the value is the data type int, right? So here's where we're kind of flipping things, right? So if you're thinking that the keys have to be numbers, they don't have to be. They can be anything, right? And so we're going to put in letters in one spot and then count integers in the value spot. And it says print the total for each letter. So we're going to try to have the user do this. The rain in Spain stays mainly in the plain, and then it'll count it'll identify all the letters, count them, and store them. So this is kind of an interesting little problem. All right, let's start by doing some basics here. I'm going to comment out my old code. I'm just going to leave it there. And then we'll just create some space to work, basically. And let's start by prompting the user for some input. So here's the code for that. So enter a string, like, type something, whatever you want to do, then we can capture it. Should I probably put a question mark here? Yeah, probably. Make the underline go away. Then we're going to build a dictionary. And as the instructions said, we're going to use a character as the key and an integer as the value. We notice how we define it. So we say dictionary, angle brackets, character, comma, integer. And then we do the new thing with a parenthesis at the end, and that creates the data structure. It is empty. And I don't know if you guys are picking up on this. A dictionary is dynamically sized like a list is dynamically sized. So pretty useful. All right. So what they want us to do now, and this is where it gets kind of interesting, is all right, we got to take the string that was typed in and we want to go character by character through the string. Now, we should start to understand now that strings are actually arrays of characters. So we can treat that string like an array, just straight away out of the box. So where does that reside right now? Whatever they type in at the prompt is going to sit in this variable. And so we can traverse that character by character. So that's what we'll do here. What I put in as a comment last time was this. And then I built a for each loop to do it. And I'm going to just type this in manually here. You guys should do the same thing. So for each character, and I'll just call it C for short, in the string or data structure, if you want to look at it that way, called input, we are going to run a for loop. So let's close our parens there and then put in our curlies. And then let's do some tricks. So like one thing that we could do, right, is like what happens if they type in a space? Do we really want to count the spaces? We could, by the way, right? We could count spaces as a character. They are a valid character in a string, right? Because they occupy space. So I could count them. But if I wanted to omit them, here's a little trick that you can use. You can say if, and thank you for suggesting that. If the character is, and there's this thing called is white space, which implies, is it a space, right? And what are we looking at? We're looking at the one that we're going through the loop on. So we're going character by character. So we're going to look at the character and see, is it a space, basically? And if it is, here's what we're going to do with that. We're just going to use the continue command. And I don't think I've used this in any coding examples yet. So if it's a space, we're ignoring it. We're not going to count it. Basically, we're just saying, okay, we found a space, continue, don't count it. Right? So what does the continue command do? You guys remember? That will it execute the rest of the loop?
No.
The answer, no. It'll, whatever code follows this inside the loop, it's not going to run it. It's just going to go back to the beginning of the loop and start over again, right? So I check first to see if there's a space, right? And I would say, and what I typed this in last time, so I think it's probably pertinent to include it again, is above this line, I typed in this, right? And I'd say this is optional. You don't have to do this because the example showed it counting spaces. So if you want to count the spaces, you can do that too. Right. But what if you do want to start counting the characters now? Now we just put in an if statement, and we're going to create. All right, I'm trying to think here. This dictionary up here, we called it character counts, right? So I'm going to call upon that. So if character counts, then we're going to use this method called contains key. So we're looking for a certain key value, and what are we looking for? Yeah, whatever's in the current character we're looking at, right? So if that's the case, then I don't need the curly brackets here. I'm just going to count it. And notice Visual Studio, great job at auto suggesting the code, by the way, Visual Studio. That's exactly what I would have typed. So it's going to take that. Now think about what this does. It's going to go to the dictionary, which is got that letter that we've captured stored in the key. And then in the value area, by virtue of this syntax, it's going to add one to it. Now, because the values are integers, what value does it start at? 0. So by doing a plus plus, it adds 1 to it. So it'll take that letter, add it to the dictionary, and then count it or increase the count. Here's kind of the interesting question. What if that letter is already there? Well, it would find that key again and it would just add 1 to the total, so it's not going to destroy anything. So that will count each character. Otherwise, we can do an else here, right? And I don't need to run any other checks. If it doesn't exist, right, already, then we'll just set it not to 0, to 1. But if it's there, it's going to add to it. If it's not there, we're just going to basically set it to 1, and then next time we hit it, it'll be there to count. All right, so that's all the processing we really need to do inside the loop, believe it or not.
Don't you have to add, if that key's not there, don't you have to add an entry with that key?
Yeah. This, Bob, good question. This would actually do it right here. So that would take the character, right, which whatever it is, it happens to be in the string, will create that key and add its value at the same time. It's a really beautifully simple architecture. And okay, granted, there are other ways I could do this. I could use the add method to do it also, but this is the brute force method. And I like this approach better because it just correlates. And the proof is in the pudding. We'll see it like actually do the work. And for those of you that are coding this, if you want to have it as an example, here's the whole for loop. Just so you don't have to type it. If you were typing it, well, you should have waited. And I'll give you the output statement right away too. Here's the example. And I'm just going to put that in my code. So this is going to print the results, right? And then notice how we're going to go through there. And I'm using the var approach here, so I don't have to say that whole like key value pair combo thing. That'll pick up the fact that there's a key value pair. It'll show the key. It'll show the value with a colon in between. So we'll see all the letters. And if I want, I could make it like the slide. I could say occurred X times. So I could say key occurred like that. Right. If you want to match the slide. Right. So let's go ahead and run this, see how it runs. And then we can play with a number of different strings here. So let's come up with something interesting. So what should I type in? Where are the Packers playing next? Let's see. The Packers will beat the Vikings this week because the Vikings blank, 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 blank. We'll make it a 4-letter blank, 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 right? And an exclamation on top of it all. All right. So let's press enter on that. And notice it even picked up the comma, the underscore, and the exclamation point. And if I wanted it to pick up spaces, I could just remove line 150, on my screen right now. So I think this is kind of interesting, right? That, how easy it is to kind of use this data structure, but also to show you that a dictionary doesn't have to be, the key doesn't have to be numeric, and the value doesn't have to be text. It can be anything, right? And the lookup for the value is the letter. And really, you can do all sorts of kind of crazy stuff to it. Now, think about this. Because the value in this scenario is changing, right? That's the one we put in the value field. The key has to be unique, right? So eventually, if the key has to be unique, right? And I didn't even notice this, but the capital T is different than the lowercase t. And I didn't type a sentence with a lowercase t. No, I did. Okay. So there's an uppercase T once, a lowercase t 4 times. If I wanted to, um, you know, convert the characters to upper or lowercase and just check for unique letters, that's different than uppercase and lowercase. So you can get very granular with this, and I think this is kind of interesting. But a dictionary is a fun data structure. The thing that is pretty interesting about it, right, is when you look at how a dictionary is put together as a data format, and I want you to just look at this part of it, right? The curly brackets, the comma separated, and then really the one difference you'll notice in the example I'm about to show you is the comma inside here. But if you look at, let me see if I can find a browser window here. And I was doing this example for my Python class over at Gateway. Take a look at this data structure, which is JavaScript object notation, right? Which is basically the same type of data structure, which is a key and a value, right? A key and a value separated by commas. The only difference between this format, really, and the one that we see in C# is the dividing character in JSON is a colon. And in Python and in most other languages, it's a colon. C# uses a comma. But this transmission format is so common. And I teach this to my web students, and I teach it to my data analytics students. JSON, JavaScript object notation, which is key value pairs, has kind of become the #1 transmission format for data across the internet. So when I grab data from a website or pull it from a database, extract it from a spreadsheet, it travels with the data, which is the value, and if it's coming from a database or spreadsheet, with the column name, so it has meaning as it travels. So when it gets to the other end and you get the raw data, it's pretty easy to figure out what the data is, right? And that format, the key value pair, also called an associative array in many languages, is a really common way to move data around in applications, and therefore very powerful, right, in a lot of useful kind of ways. And folks, that's going to cap the lecture for tonight. So I'm going to go ahead and say this video is done here.